Okay, so we're back for video 2 now on this drawing ray diagram stuff, and I think you're going to start to get the hang of this pretty quickly. The first part on step 2 says find a concave mirror and hold it at arm's length away from your face. I'm just reading this part here. Slowly move the mirror closer to your face. What happens to the size of your image? Check with your classmate to confirm your observations. Hopefully you and the classmate you checked with said the following stuff. Hopefully you said image gets larger. If you didn't, do it again. Okay, the image should get larger. That's basically all you're going to observe. It stays upside down, so it stays inverted. So you're just moving this a little bit, not all the way to that blurry place, but just in somewhat from where you had it out at arm's length. Okay, so an object is held in front of this concave mirror, and the object you see looks inverted and larger than the actual object, and it can be projected on a piece of paper. Okay, in order to produce this image, would the object be placed closer to or farther from the mirror than in the previous part? Hopefully you said closer to, because that's what you just did. You just brought that thing closer. Is the image real or virtual? Hopefully you can answer real and explain why. And now watching video 2, that's what you're doing. So we want to draw another ray diagram, hoping that you're getting the hang of this. First thing we want to do is draw another concave mirror. Okay, if you want these mirrors to look perfect, you can use the back edge. So you could take a protractor and set it right along here and draw along the back edge of the protractor, or those little mirrors that we have. You can draw along the edge of those. That'll give you a nice curved shape. For me, I'm just going to rough it because I don't have a protractor big enough to fit on this computer screen. Okay, next thing we want to do is we want to draw this picture to scale. So our focal length is still 10 centimeters. Okay, and I'm going to do the same thing I did the last time. 1, 2, 3, 4, 5. I'm going to put F here. 1, 2, 3, 4, 5. I'm going to put 2F. And it says that in order to produce this image, is this image real or virtual? Watch this video. Well, in order to get this image this time, I'm just going to tell you, and then we'll figure out later, that as I moved the object closer in this way, the image got larger. The blurry point we learned in class, or you will learn in class, is when you put the object right at the focal point. We're not putting it that close to the mirror. We're putting it someplace out here. Okay, so I'm going to go ahead and draw my object in between F and 2F, right about there. If you didn't draw it exactly that spot, that's okay, but someplace out here. That is my object. And what I want to do is figure out where my image is going to appear. So I'm going to do the same thing I did the last time. I'm going to trace where certain light rays go. Again, remind yourself that light is going out from this candle in every possible direction, because you can see that candle from anywhere. We're just tracing certain light rays because we know exactly where they go once they reflect off the mirror. So our next thing we're going to do, let's go ahead and put this on blue. We'll draw a light ray that comes in, again, parallel to the principal axis. And where does that reflect out? Reflects out back through the focus. Feel free to include sound effects if you like. Is one of my favorites. Don't know what that's going to sound like on the video. Okay, and then I'm going to give that arrow, those rays some direction arrows to tell people, hey, this is the light ray coming in, this is its reflection. Okay, all right, next thing I want to do. I want to take a light ray and do almost the same thing, but I'm going to draw that light ray coming in now through the focus. Okay, now some of you, depending on how big you drew your object and how big you drew your mirror, this light ray might miss your mirror. If it does, draw your mirror a little bigger, and in the future draw your object smaller. I usually make my object, like if these are 2 centimeters, I usually make my object only about the same distance apart as these are. It just makes my diagrams neater. I just do that without thinking about it. All right, well, the light ray that comes in parallel, it reflects out, the light ray that comes in through the focus, I just answered my own question, reflects out parallel. Okay, it's just kind of that blue light ray in reverse. So I want to draw it so it reflects out parallel. I'm not particularly satisfied with that light ray. I think it's all right, but it's not perfect. I'm going to undo it and redraw that one again. So let's draw it again like this. See if I can do a better job. Looks a little better. You might be saying, that looks exactly the same as you just drew. Well, you're probably right, but close enough. Okay, now, in my picture, did these 2 light rays strike each other? No, not the way I've got it drawn. But are they going to strike each other? Is this blue light ray going to meet this red light ray someplace? Yes, you can tell they're clearly headed the same place. If that happens in your diagram, well then just extend that light ray. Okay, so I'm just going to extend this one. I'm being lazy because I don't have a straight edge handy, so I just extended it without a straight edge. Didn't do a great job. I'm going to extend this one a little bit. But the idea is that I can tell that these two light rays are going to strike someplace. All right, at the place where they strike, that is where my image appears. So I'm going to start at the principal axis and draw upside down the image of my candle. And again, I'm using a candle because in the lab we're going to do later this week, you're always going to be using a candle. Looking at that image, how would we describe it? Well, the first thing I can say is, since light rays actually come together and meet there, it is real. I could put a piece of paper here, a screen, and project that image onto it. So that image is real. Second thing, it is inverted because it's upside down. I always start from the principal axis and extend down until the light rays meet. Okay, is it larger or smaller than the object? Pretty clearly, it is larger than the object. And finally, where is it located? It looks like beyond 2F. So if you're looking at your last two diagrams, the first one we put the object out here and the image was in between F and 2F. The second time I put the object out here in between F and 2F and the image is beyond 2F. It kind of seems like as I move the image or the object in, the image goes out. It also seems to make sense then that if I put the object right at 2F, the image might also appear right at 2F. That's just a guess. I don't want to give away too much, but that seems to be logical. It seems to make sense. Okay, well that is the second ray diagram thing that we're doing, and it explains that when you put this object here, by following these light rays, we can figure out where the image is going to appear, and we can explain to ourselves then why the image that we saw is actually what we did see. Okay, so that is video 2.